Hi, we're going to look at section 2.2 graphs. Our objective is to hand draw graphs of function using a graphing calculator, getting limited values from a graph. Graphing calculator is great to find the coordinates of key features of a graph, such as maximum value, minimum value, x-intercepts, y-intercept. Example 1. Using our calculator, let's determine whether this function has a maximum or minimum value. I already have my equation typed into my calculator. I'm going to use the zoom key to find me a window. I'm going to use the standard window here. So that's number 6. So zoom 6. Great. This is a picture of my graph. It opens up. Therefore, I have a minimum value here. Now let's find the coordinate of the vertex. This is the vertex here, the lowest point. So I want to find the coordinate. I want to calculate that value. So I want to go to calculate above the trace key. So in order to get there, I hit the second trace. So second trace. And we say we had a minimum value, number 3. So I hit number 3. It says left bound. Now I'm going to move this cursor by using this left arrow to get to a point to the left of the minimum point. So I move that over, hit enter. Now it says right bound. Now use the right arrow key to move the cursor to the right of the minimum value. Hit enter. Now hit enter again to get my coordinate. So my coordinate is negative 0.92, comma negative 2.04. Now it wants me to graph or to find the y-intercept and the x-intercept. The y-intercept is right here. It's where the graph crosses the y-axis. At the y-intercept, the value of x is 0. So again, I'm going to calculate the value 1, and the x value is 0 for the y-intercept, and it gives me the y-intercept is 0, 3. X-intercept is where it crosses the x-axis. We call these zeros. So we want to find the x-intercept, second calculate. They're called 0, that's number 2. Now this time it says left bound, but this left bound means, and one on this side of the line, the left intercept here is above the line. So I move, using my left arrow, I move this cursor to above the line, hit enter. It says right bound, move below the line, enter, then enter one more time, and gives me my coordinates, negative 1.50. Now I'm going to find the coordinate of this side here, the right side, the x-intercept. Again, second trace. Number 2, left bound. This time, left bound is below the line. So hit enter. Right bound is above the line. Enter. Then enter one more time to give me my coordinate, negative 0.33, comma 0. Now I want to graph all these key features. My vertex, y-intercept, and x-intercept on this coordinate system here. So I'm going to plot my vertex, my y-intercept, x-intercepts, and then my graph. So this graph looks like my graph I have on my graphing calculator. Now let's look at getting limited values from a graph. Example 2. The amount C equals C of T of cholesterol in milligrams per deciliter in the blood of a certain man on an unhealthy diet is given by this formula. T is measured in time, the time is in months. Sketch a graph and make a table using increments of 10, that shows the blood cholesterol level as a function of time if the unhealthy diet is continued. Use your calculator. We're going to use the window for X from 0 to 50, Y from 0 to 300. So go to Y equals, clear out my graph here, type my new one in, 235. So 235 minus 105 times E. E is above the ln key, so I get there in a second. Raised to the negative 0.3t. Use x for your variable. Now my window for my x from 0 to 50, and I'm going by tens. My y is from 0 to 300. Let's go by 50s. 300 is pretty large. So I want to graph this and see what's going on. This graph looks familiar. It increases rapidly at first, then the rate of increase slows down, and then it reaches limited value. So we can tell that this graph has a limited value. Let's look at our table of values. Let's set our table, a table from 0 going by increments of 10, the problem says. So the table set is right here above the window key. Table, so second window. I want to start my table at 0, and I want the delta, the change, is 10. So for 0, 10, 20, 30, 40, I'll give my values for those numbers. I want to keep it on auto because I want my calculator to do the work for me. So to get my table, the table's above the graph key. It's in blue, so I have to hit the second graph, and it gives my table of values. I'm going to copy this table of values on my paper, and without doing any extra work already, I can see that my limited value is 235 because it starts repeating itself. So I already know the answer to one of the questions. Let's go back to our questions. Here I already have the table typed in for us. Now we want to graph this table, a rough estimate, a sketch. So at 0, it's 130. So 130 about right here. I'm going to put a dot here. At 10, about 230. $40, 235. And then it stays at 235. So let me draw my graph in. This is a sketch. Now let's answer part B. The doctor has issued a warning that this man may experience severe health problems if cholesterol levels more than 200 milligrams per deciliter of blood are reached. Is there a danger of exceeding this level? The answer is yes. We see that maximum value that from this graph can be 235. So remember to answer in a complete sentence. Yes, there is a danger of exceeding 200 milligrams per deciliter of blood. Part C. If unhealthy diet is continued indefinitely, what actual cholesterol level will be reached? And we know that's the limited value of 235 decilgrams per deciliter. Okay. Last question is the graph of C concave up or concave down? Explain in practical terms what their answer mean. The graph is concave down. The cholesterol level is increasing at a decreasing rate. The rate of increase slows down as it reaches its limited value of 235 milligrams per deciliter. So we can use our graphing calculator to help us find key features of a graph. Now, in your lesson, I also posted some additional videos to help you use your calculator. Please look at those also. If you have questions, please contact me. Thank you and have a good day.